Hello guys, so today I'm going to show you something that is like actually very simple to make and most people don't know how to do it, which is like having a stretchy whatever, spine, arm, leg, whatever you want. Like, well, right now I don't have it, but I'm going to make it. And also make it scalable in the from the very beginning of the rig, like in the root, right? So that process is called normalizing the rig, and it's actually very easy. So I'm going to show you how to do this. Okay, so I'm going to create a very simple stretchy rig. So I have this here like spine, and I'm going to create an IK spline handle, selecting first and last. And this curve I'm going to rename it spine CV, and this I'm going to call it spine IKSP. IK single spline solver. Okay, so I'm going to make a stretchy here, creating, yeah, let's go from scratch. Selecting the spine CV and creating a new curve info and a new multiply device. So I'm going to put names to this. It's going to be spine info, and this one is going to be like spine stretchy div because it's going to be a division. So I'm going to connect the workspace 0 to the input curve of the spine info and the arc length of the spine info into the input 1x of the spine stretchy div. And what you do for basic stretchy is like dividing the variable value in between the constant value. So it's the same value dividing by itself and put it in divide obviously. So 8.218 is divided into the same is going to be 1, which is the scale of the joints. Okay, so you connect this division to the scale of the joints. Which scale? Well, you see this is x scale, so you connect it to the x, right? Because of the orientation of the joints. And you only connect the first, you don't connect the last one, okay? So you just put them here and connect the output x into scale x, output x into scale x, output x into scale x. And by doing that, you already have like connection in the scaling. And if you put if you make something to control the curve, for example, like selecting this, right? You're going to have stretchy joints. So let's make something. I don't like clusters, to be honest. You can use whatever you want, but I don't like clusters, so I rather use like joints. Okay, so oops, why is it creating? Okay, huh, well, awesome. Okay, so let's create just two of them, two joints to control the beginning and the end of the curve, and it's going to be like spine start and spine end. Okay, so this and this to the spine control, skin, bind skin, select the joints, bind skin. So now you have, oh, oopsie, to the spine CV, sorry, skin, bind skin. Now you have this, okay? Now you can put the end inside the controller, and there you go, right? Okay, so you have the stretchy spine there. So the thing is that if you select this spine the spine control, the spine ICA spline, and the spine, everything in the spine, yeah, right? And you do a group, and then you name it spine group, and you move it. You're going to have double transformations because you have the skin the skin curve right here. So you can remove the extra double transformations by just selecting the spine CV in the attribute editor and removing the inherits transform. So it's not going to have double transformations anymore. So you have just like a normal spine, right? With stretch. Okay, everything cool. If you put the spine group inside the root control and you scale it, you're going to have double transformation of the scaling, right? So to normalize this, you notice that the one that is causing, for example, if you do this, is not actually doing double transformation, and this either. But if you do this, right? So it's the scale y which is causing the problem in the scale x. So what you're going to do? Oh Jesus, okay. Is selecting the cleaning this first. Okay. Selecting everything you did here. Let me just hide this because it's too much. And this. Okay. And what is this? Yeah, you too. Get out. Okay, so you're going to make a in-between node in here, which is going to be a divide, a multiply divide. Okay, and it's going to be called spine normalize div. Okay, and you're going to connect like the same, oopsie, you're going to connect like the arc length to the input 1x and the output x into the input, sorry, the output x into the input 1x. By doing this, you're doing literally nothing. You're just multiplying this by 1, okay? And you don't want to multiply, you want to divide. And what you're going to make is to select the root control, which is causing the trouble, and you remember is the scale y, which is causing the trouble. So put it in here and select the scale y, put it into input 2 x, put it in divide, don't forget. So this is normalizing, right? Because now you have the variable scaling of the spine and the variable scaling of the control. Let me just make a copy tab here. So if you select the root control, now you have a division that is normalizing this and is not creating any double transformations. So that's how you normalize a rig, and you have like globally and locally scaling. And if you want to create a squash, you don't need to worry about the rest of the um, edges, because the only one causing trouble is this one. Okay, so that's it. You can create a squash without any doubt, and it's going to work fine. And that's how you normalize a rig. Hope it's useful, and thanks for watching.